Hi guys, I want to go over the homework that was due last week, pages 4 through 7. So I'm going to go over this pretty quickly because it's all review, and please feel free to email me if there are any questions. 10 is going to be D. 11 is going to be C. 12 is going to be B. Remember, mixtures can be physically separated. 13 is B. 14 is air, because air is composed of nitrogen and oxygen mixed together. Water is a compound, so that's not a mixture. Magnesium is an element, and methane is a compound. 15 is B. 16 A. 17 a true solution is a homogeneous mixture. 18 is air, as long as it's clean. 19 is C. 20, if you have sugar, the key word is dissolved in water. It's going to be definitely not a compound, right, but a homogeneous mixture. 21, a heterogeneous mixture would be soil, because there's like sticks and worms and stuff like that. 22, used to separate liquids, differences in boiling point, that is distillation, which is actually the setup is right there. So that is a distillation setup where they're boiling it. See, notice the Bunsen burner, and it's separation based on boiling point. The best answer for 24 differences in solubility would be B, filtration. Okay, the next page, this definitely looks like familiar homework that you've gotten a while ago. So they want you to draw a mixture of these two compounds. So if you using those elements, so that could be one compound, and then maybe another compound could be something like that. Number 2, a mixture of elements only would be Z. These are both, this right here, these are two diatomic elements, like maybe F2 and Br2. This would be just one diatomic element, say I2, and this would be a combination of a compound. So X is a compound, Y is a single diatomic element, and Z is a mixture. The next one, a mixture that could be homogeneous, or matter that could be homogeneous, would be a mixture. A mixture, again, you're looking for two separate things or more. Homogeneous mixture, again, mixtures can be separated physically. Mixture, these are some repetitive questions. Air. Okay, so I want to go a little slower on this one because I noticed some of you got this one wrong. So when a mixture of water, sand, and salt is filtered, what passes through the filter paper? So in Regents chemistry, it's always assumed that salt and water are completely, totally, uniformly mixed, and the salt is completely dissolved. So what passes through the filter paper is going to be both the water and the salt. 9 is a filtration apparatus. So if you're using a filtration apparatus, you are looking for a solid and then something either water or aqueous. So the answer is 1. So the key, again, you're looking for the parentheses S. 10 is a very similar question to 8. So what is found in the beaker after filtering would be salt and water. Okay, 6, the infamous rock question. So student X said that they have a different amount of material based on mass, so something like that or something like that. So they both contain lead and sulfur, whereas student Y said that they contain different compounds of lead and sulfur. So the difference would be something, student Y would have an explanation like this. So again, student X, if you look in the passage, just says that there's different varying compositions of lead and sulfur. And then student Y was specifically saying, let me just make that a little clearer, that there are different compounds made of lead and silver. So they just have to be stuck together. 12, distillation, we're again, separation on boiling point. 13, distillation, separation on boiling point. 14 is some of the new stuff that we're going to be talking about a little bit more today. And what you're looking for is opposites attracting. So when you have the water molecule looks like that, and if I draw the electrons around oxygen, this side of the water molecule is very negative. This side of the water molecule is positive. So when we're looking at salt and water NaCl dissolving, you're looking for the positive ion to be closer to the negative part of the water molecule and the negative ion to be closer to the positive side of the water molecule. So that's 1. Okay, 15, I did notice some of you got this one wrong. So solid potassium chloride is KCl. And I have notes with respect to this today. So if it is ionic, it will dissolve in some things that are polar. So make sure you watch that video. So polar dissolves polar, ionic dissolves in polar, and nonpolar dissolves in polar. So the answer to this one would be 4. And then lastly for today, question number 12, a nonpolar symmetric molecule is B. 16, Lewis electron dot structure. So again, we're writing hydrogen and oxygen, just writing down the valence electrons. And then a water molecule would be, I kind of like to do the X's there to represent the valence electrons of hydrogen, would be that. Symmetric is going to be A. Solid water, you're going to have covalent bonds, which is between the H and the O, and then between the water molecules would be a hydrogen bond, so it's D. And then you could say a couple ways that they are similar. So I like they're both covalent. Some of you wrote they're both single bonds, which is okay too. And then the way they're different is that one is polar, HCl, and Br is a nonpolar covalent bond.